Out. Where we left off last time was we talked about, as we just reviewed real quick, the complement, the intersection, and the union. So that brings us to the fourth of our major set operations, which is called set subtraction. And so the subtraction of set B from set A is the set of elements in A, but not B. Another way to think about that, maybe a little bit of an easier way to think about that, it's if you're taking set A and you're subtracting set B, as this notation is showing you here, it's just a subtraction symbol, just like arithmetic, then what you're looking for is the stuff that is in A only. Okay, that would be another way to say it a little briefer. So on my Venn diagram, when I come over here, and here's my universe as we've been labeling before, and here's my set A, and here's my set B. Instead of doing a whole lot of coloring here, I'm just going to ask you to identify. We've got. I'm just going to use a little Roman numeral. We're going to get more used to this in the next section. But I'm just labeling the puzzle pieces. Like if this is one of those kids puzzles that have the big pieces and you got to fit them together. If this was piece 1 and this was piece 2, this was piece 3, and out here is piece 4, which one of those puzzle pieces represents the subtraction, meaning the stuff that is in A only? Yeah, 1. So what subtraction means is here's set A, this big full circle, and what you're doing is you're subtracting anything that it shares with B. And so what you're going to do, and here's how you'll color your Venn diagram, is it's this bit right here that looks like a cookie that somebody has taken a bite out of. That represents the set subtraction. Now, all along, we have been also talking about set builder notation, just trying to keep you apprised of that is something that if you were actually studying sets a little more, you would be using it. And so the set subtraction is the set of values X, such that so far all of our set builder notations have started off the same way. And the reason I've been mentioning the set builder notation is because of the very last set operation. I wanted to show you a little bit of a difference. So it's the set of values X such that X is an element of A. Okay. Remember, and it's good to keep us current of this symbolism. This E with the corner shaved off means is an element of, and then X is not an element of B. That would be how you describe it in set builder notation. Just giving you a minute to get caught up writing, and then what we're going to do is we're going to turn to the bottom of the next page where we've been doing examples with our given universe and our sets. So I hear a lot of pages turning, so I'm going to turn my page as well. And so again, if you're watching the video, I hope you've printed out this, but if you haven't, pause the video. Here's your universe, 1 through 10. A is 1, 2, 3, 8. B is 1, 3, 6, 7, 8. C is 1, 3, 4. And D is 5, 7, 9, 10. And the first thing that we're going to do, and I'm going to slide back up there, but the first thing I'm going to ask you to do is we're going to take set A and we're going to subtract set B. We're going to take set A and we're going to subtract set B. So I'm going to slide back up so I can view my sets up here. So what I'm starting with is right here. I'm starting with set A, 1, 2, 3, 8. And what I'm going to do is I'm going to go through and I'm going to subtract a thing. In fact, just because I have a little space over here so that I can do it on the camera and so that everybody can see, I'm going to write the answer to A minus B right here. So starting with set A, here's the question you're going to ask. Is this element also in B? So is the number 1, is that also in B? Okay, then I'm subtracting it away. Goodbye. Is the number 2 also in B? No, so 2 is going to remain. Is 3 also in set B? Yes, so we subtract it away. We're subtracting anything that is in B, anything they have in common. Is 8 also in B? So we subtract it away. So the only thing that remains when I do A subtract B is the element 2. Now, a very common question, and if you're thinking it, you're right where I need you to be. A common question is, hey, Perkster, how about those elements of B that are 6 and 7 that are not in A? They have no bearing on this problem. Okay, the only things that matter are the things that B and A share, and you subtract them away. So in every one of these problems, you're going to do two more. We're going to do 2 more of these. You're going to start with this first set, whatever one comes first, and you subtract away whatever's in common with the second set. So down in exercise 10, I'm not going to slide the sheet. I'm just going to rewrite it. I'm going to give you a moment. I want you to take set B. That's what you're going to start with. And I want you to subtract C from that. So set B is 1, 3, 6, 7, 8. That's what we start with. We always start with the first set listed, if you're wondering that. We start with set B, and now we're going to subtract off the things it shares with C. So here we go. Is 1 in C? Subtract it, it's gone. Is 3 in C? Subtract it, it's gone. Is 6 in C? No, so 6 remains. Is 7 in C? Nope, 7 remains. Is 8 in C? So 8 remains, and there we go. The only elements left are 6, 7, 8. Anybody got something different we need to talk about? There's one more set subtraction problem that I'm going to have you do. It's at the top of the next page. I just reversed the order. Instead of doing A minus B, just to make sure we're clear that you're always starting with the first set listed, I want you to please do B minus A. So this time you're starting with set B, and you're subtracting set A. All right, set B is 1, 3, 6, 7, 8. We're subtracting A this time, so we're subtracting anything common. So what am I going to do with 1? Do I subtract it or keep it? You subtract it because it's also an A. What do I do with 3? Do I subtract it or keep it? Subtract it, it's also an A. How about 6? Subtract it or keep it? You keep it this time, it's not an A. How about 7? Subtract it or keep it? Keep it. And how about 8? Do I subtract it or keep it? Subtract it because it's also an A. There you go. There's what's left. Any questions? Please ask if you've got to. I know this is goofy stuff, some of it, but it's fun. All right, next page. If you remember last time, I had given us this drawing right here, and you can see the work we already did on it in the last class. So what I would like you to do right below it is, again, subtraction. So I want you to take set A minus B. I want you to write down what that set is. A minus B. So if I start with A, I subtract off B. Remember, subtraction means what is only in A. What elements are only in A? Yep, A and I. Perfect. If you feel good about that, do the next one. If you don't feel good about that, that's a great time to ask a question. If I start with B now and I subtract A, what is the elements or what are the elements that are only in B? Sure. D, G, H, K. Perfection. The three, if you've got a question, again, ask it. You're not an interruption or an imposition. I love questions, but I'm just going to keep going because I'm having a great time. The next three questions I ask right below, this is just a little review of notation. So if you can answer each of those, what does, if you remember, hopefully, what does n parentheses A and n parentheses B mean? And write down your answer to that. And if you don't remember, then you'll see in just a minute. We'll reflect on it. What does n parentheses A? Does anyone remember what that means? Yes, that's called the cardinality, but it doesn't matter if you remembered that word or not. You just need to remember it's the number of elements that's in that set. So what is n parentheses A? How many elements are in A? Okay, this is not a set, by the way. So if you wrote squigglies around that, that's technically wrong. It's bad notation. It's just the value 5. It's a number. How about n parentheses B? What is that? Yep. Spot on. We calculated A union B last time, and the answer's still on the page. What is the cardinality of A union B? You didn't sound super confident, but I think you got it. Yeah, you got it. 9. Now, here's something interesting that happens, and this will be something, we're not going to use this too much here in this unit, but this is one of the minor topics that will pop up again when we get toward the end of the class and we talk a little bit about what's called probability. But notice this. The number of elements in A is 5. The number of elements in B is 7. But what happens when I add 5 and 7 together? 12. That's more than the number of elements in the union, right? Why is that? Why is 5 plus 7, when I add those together, and I get 12, why is that more than the number of elements in my circles? Yes, because of the elements that overlap. So for that reason, okay, there's this little formula reminder that tells me this, and it's down at the bottom of the page here. It says the number of elements in A union B. Well, it's equal to the number of elements in A plus the number of elements in B, just like we would expect it. We're adding everything in the first circle plus everything in the second. But just as was mentioned, when I add everything in the circles, I'm just going to slide the page down and I'll finish that. When I add everything in the circles, notice when I count up the A's, I've got 1, 2, 3, 4, 5. When I count up the B's, I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. But notice what I did is I counted these things twice. So what I need to do then to get an accurate representation is that I need to subtract the number of elements in the intersection. So what is right below it, exercise 12, is intended to be just a fairly straightforward problem to see if you remember. In that problem, I've given you the number of elements in A, the number of elements in B, I've given you the number of elements in the union, and so then you are asked to find how many elements does that mean there's in the intersection. So it's kind of intended to be just a quick plug and chug on that formula. So put the appropriate number in the appropriate place and then see if you can figure out what's left over. Well, the number of elements in A union B, I'm just going to draw a little arrow and not rewrite the whole formula. The number of elements in A union B, I've told you, is 14. It's the number right there. Equals the number of elements in A. Again, I'm just going to draw a little arrow down so you can see where I'm plugging this in. The number of elements in A is 7. And then plus the number of elements in B. The number of elements in B I gave you was 11. Minus the number of elements in A intersect B. I have not given you that. That's what we are looking for. So I don't know how comfortable you are with a variable. You can use that. I can just use a question mark to make it look a little less scary. You can put a square there if you want, just to see. So I need to figure out. Now you can use your calculator if you want. This problem has this is kind of the amount of algebra that you're expected to know in this class, is how to solve a straightforward linear equation. So what I'm going to do first is I'm going to add the 7 and 11. 7 and 11 is 18. Does anyone remember, just to bring us all up to speed, what am I going to do to solve for the question mark? What do I have to do with the 18? I got to subtract it. I got to bring it over to the other side. So I'm going to do that. I'm going to subtract the 18. So whoop. Your calculator will tell you 14 minus 18 is -4. And then I have a negative in front of my question mark, or my X, or whatever you're using to represent what we don't know. And then the very last thing is I'm going to divide both sides by what on this problem? Yeah, -1. Got to get rid of that negative. And in arithmetic, a negative divided by a negative is a positive. A negative divided by a negative is positive. So the missing value, my question mark, my variable, whatever you're using, is 4. So that is what the number of elements in A intersect B is equal to 4. Yeah. Okay, so what you did is you brought the 14 over here, and then you brought the variable over there, and that is a perfectly legitimate way to do the problem. Yes. Yes, and this problem also is simple enough that I'm sure, like when you saw 14 equals 18 minus what, that you could have just said it's 4. Okay, but I'm just reminding us of solving, because we will solve things just at a couple different occasions, but they don't tend to get any more complicated than that problem right there. Okay. All right, I've got one more thing in this section. Does everybody feel okay so far? All right, well then the last thing is the very last of our 5 operations. I'm back on page 2. This is where we're going to finish. So the last thing is called the Cartesian product. That's what our book calls it. Other books will call it the cross product. I don't care what you call it. You can just call it the product. Although there are other types of products if you talk about set theory, but this is where we're ending our quick little discussion of the operations. So if you say product, I will know what you mean. So the Cartesian product of set A and set B is this. It is the set of ordered pairs formed from elements of set A and set B. And it's denoted in the usual multiplication way that you were used to when you were in elementary school, when we all use the X for multiplication. So at this point, we've been talking a little bit about the set builder notation. The set builder notation, this is where we get a little bit more interesting with our set builder notation. And so this time, for the first time and the only time in this class, and this is the whole reason why I've been bringing it up, is I just wanted to show you how set builder notation works. Now we have ordered pairs. So this is the set, not just values, this is the set of ordered pairs. So I'm going to write the set of ordered pairs, X comma Y, such that. So now the format of my elements of my set are not just values, they are ordered pairs. And so the constraints here are that X is an element of my first set, which over here we see is A. So X is an element of A, and Y is an element of B. And that's how you write that in set builder notation. So I just wanted to show you that not always when you use set builder notation is it just the set of values X such that that first part depends on the format of your set. Okay, well, what you are interested in, though, is logistics. You want to know how to form the cross product, and I don't blame you about that. So over here, I've got a fairly relaxed little example. I'm using some small sets just so that we don't die under the labor here. So I've got A is the set ABC, B is the set 1, 5, and what I'm going to do is I'm going to form the cross product A cross B. So here goes. I make a little squiggly. The key thing to remember is my set is a set of ordered pairs. The order matters. A comes first, B comes second. So for each ordered pair, I'm going to pick something in A and then something in B. And I'm going to try to do this in an organized way so that I get all of the elements. So what I'm going to do first is I'm going to use element A. So that means my first order pair is going to be A, comma, 1. And then what's my second order pair going to be? A, comma, what? I don't have a 2 in B, but what's the other element in B? 5. Does everyone see what I did there? Because I know this gets a little more complicated. It's now two-dimensional set. So I've taken the element A and I've combined it with 1, and then I took the element A and combined it with 5. If there was something else in set B, I would do A, comma, whatever that was, but there's not. So I'm done. Now I'm going to move on to element B, and I'm going to do the same thing. So I've got B, comma, 1, and then B, comma, 5. Those are the next two. And again, if there was anything else, I would make an ordered pair out of it, but there's not. And so then what are the last two ordered pairs in this set going to be? C, comma, 1, yes, C, comma, 1, and then C, comma, 5. Perfect. There's no other ordered pairs, so I'm going to end with my squigglies. What I would like you to do, please, then, unless you have a question, is do B cross A. So the only difference this time, the first part of your ordered pair is something from B, and then the second part of the ordered pair is something from A. And then if you're done with that and you want to, you can finish out the last 3 questions on that page. This is going to take us to the finish line of section 2.3. So if you've got anything bubbling up in your mind as far as questions, please feel free to ask, be aggressive, do what you need to do. So B cross A, something I didn't mention, as long as you have these ordered pairs, it doesn't matter what order, if you started with the C's, and it doesn't matter. I try to be linear in my thinking, otherwise I will overlook something because I'm very forgetful. So I'm going to start with my B. What element of B are we going to start with? Yeah, sure, it doesn't matter. If you started with 5, that's great, but I'm going to do 1, comma A, and then I'm going to do 1, comma B, and then 1, comma C. So notice the difference. This time I've got my first element is something from B. The second element is something from A. The order that you're given your cross product matters. Okay, that's why I had us distinguish these two problems, if I could speak. And then we've got 5, comma A, 5, comma B, and 5, comma C. And there we go. There's my 2 sets. Any questions about the cross product? All right, well then what's the answer to the next one? What is the number of elements in A? 3. What's the number of elements in B? And then the number of elements in A cross B, how many were there? Yeah, there's 6 ordered pairs. Do you see a relationship there between those numbers? 3 and 2 as A and B, and then the number of elements in the cross product. Yeah, and that's not accidental, okay? That's not just a coincidence. So again, these 2 last little bits of trivia, they're interesting, I think, but they're going to be useful to us when we get to the probability chapter. This will help us and become something called the counting principle. You don't need to know that right now, but when we get to probability, that'll be something we talk about. So in general, with your cross product, the number of elements in A cross B is equal to the number of elements in A times the number of elements in B. And with that, we're done talking about the operations on two sets. So I'm going to end this session.